the next one we're going to look at is the square root family. The parent function here is y equals the square root of x. We've looked at square roots, but we never actually graphed them. So I need to show you what those look like. So let's think about the parent function here. What's the smallest number that you can put in for x and actually take the square root of it? And hopefully you're saying 0. Can't take square roots of negative numbers. So the smallest, or the first point for this, is the point 0, 0. The next number I'm going to keep it easy on myself. I'm going to put 1 in for x. What's the square root of 1? 1. And now you could put in 2, but you're going to get a decimal, and we want to stay away from that. The next perfect square is 4. 1, 2, 1, 2, 3, 4. When I take the square root of 4, I get 2. And what the square root function looks like is kind of half of a parabola on its side. It looks like that. To get the whole sideways parabola, you'd also have to have a negative out front, and that would be traced down here, but we don't have that. So let's talk about our transformations. The 3, we're going to take our y's times 3. We're going to go to the left 1, and we're going to go down 2. So here we go. Let's take my parent graph. So I take my y's times 3. The y here is 0. 0 times 3 is 0. Need to add on more tick marks. Okay, so 0. I have to go to the left 1 and down 2. Boom. This is the point 1, negative 2. Negative 1, negative 2, sorry. Next point is at 1, 1. So I have to take my 1, the y value, times 3. Didn't do a good job adding on. So 1 times 3 is 3, so that brings me up here. I have to go to the left 1 and down 2. 1, 2. So this is the point 0, 1. Last point, again, I want you to have 3 points on your graph. If this thing would focus, that would just be, amazing. Next point is at 4, 2. So it tells me I have to take my y's times 3. Well, the y value of this point is 2. 2 times 3 is 6. So 2, 1, 2, 3, 4, 5. Oh, I did do 6. Okay. So that's up here. I have to go to the left 1, and then I have to go down 2. So that's going to bring me to 4. So with my non-graph paper here, I believe I end up at 3, 4. And so a lot of people will look at these and they'll be like, oh my gosh, I have no idea how to connect this or where it starts. Some people are like, well, does it start here and go down like here, like this? Some people will connect the whole thing and make this big arch. I always tell people, look at the original shape. 0, 0, right? If you need to, write a little S here for start. Okay? And where did we transform that start point to? It was over here. So that's your new starting point. So you're going to still start at your starting point, and it's going to have that same nice arc shape to it. All right? Let's do one more of these. We'll call it 3A. Let's say I forgot to change that to G, oh well. And I forgot to label this, well, why? Call it G of X to stay consistent for the notes. All right. So if K of X equals negative square root of X, I'll just make it go as crazy as we will get here, plus 2 and then plus 1. So again, notice I don't give you very large numbers here because there's really no need to make the graph go off of our grid and just get ridiculous. All right. 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right. So the parent function 0, 0, 1, 1, and 4, 2. All right. So we're going to transform each of these points one at a time. This negative out front, that's a flip over the x-axis. This plus 2 means we're going to go left 2, and this plus 1 means we're going to go up 1. So here we go, 0, 0, let's start. Can't flip it over the x-axis because it's on the x-axis. This thing would just focus. Come on, okay. So that means I'm going to go left 2, 1, 2, and then I'm going to go up 1. So remember, if you got to write start, I'm going to write start and start so I know. And that's the point, negative 2, 1. Next point is 1, 1. I have to flip it over the x-axis. So now it's down here at 1, negative 1. I have to go left 2, and then I have to go up 1. So that's the point, negative 1, 0. And your last point at 4, 2, when I flip that over the x-axis, that's now at 4, negative 2. I have to go left 2, and I have to go up 1. So we are at 2, negative 1. Alright, so this one's going to be a little confusing for people. Remember, the original parent function looks like that, and we flipped it over the x-axis. So when you take that parent function, let me just do a little sketch over here. So here's just the square root of x equals y. When we graph negative square root of x equals, I'll just say f of x something else, remember that's flipping it over the x-axis. So that's going to give you a mirror reflection like I was talking about a couple minutes ago. So it's still starting at that same point when I have just negative square root of x. But it's basically a parabola on its side if you want to think of it like that. Okay? So this piece here, we did flip it over the x-axis, all right, and for the S trick, if that helps you, we started here, but now we're starting up here, all right, again, because that confuses people. Some people will be like, oh, the start's here, and it goes like this. No, it doesn't, actually. It starts at negative 2, 1, and it's going to have this downward, please focus, downward curve to it. So it's going to start here and go downwards like this, and that is your k of x. So there's the square root problems for you.